Hello students, good morning to all. Today I am starting the first unit of class 12th, that is electrostatics. In class 12th, our syllabus is divided in different units as per series. And as per NCERT, there are different chapters. As per CSE syllabus, first unit is electrostatics, and electrostatics is divided in two chapters. Chapter 1, Chapter 2. Today we will discuss Chapter 1 and some topics of Chapter 1. But before discussing chapter and before discussing the different topics, I want to recall some of the previous class knowledge of us. Class 7 से हमने देखा है, class 7 में आपने देखा कि there is a phenomena related to charging. For example, when silk is rubbed with glass or formation of clouds, cloud का formation हम कह सकते हैं चार्जिंग से होगा, clouds का formation है. हम अगर बाहर जाते हैं किसी पार्टी में तो हम देखते हैं कि हमारे जो शूज है, शूज पे अगर पॉलिश की हुई है तो वहाँ पे डस्ट पार्टिकल्स अट्रैक्ट हो जाते हैं, डस्ट पार्टिकल्स स्टिक्स हो जाते हैं. एक फिनोमेना हमने ऐसे भी देखा जो बड़ा सिंपल फिनोमेना जो कि क्लास 7 की एक्टिविटी में आपने देखा होगा कि व्हेन वी रब कॉम्ब इन आवर ड्राई हेयर्स में जो कॉम्ब को रब करते हैं, देन इट विल अट्रैक्ट बिट्स ऑफ पेपर, मीन्स बिट्स ऑफ पेपर को ये अट्रैक्ट करता है. अगर कॉम्ब को ड्राई हेयर के साथ रब करते हैं तो बिट्स ऑफ पेपर को ये अट्रैक्ट करता है. एक बड़ी अच्छी एक्टिविटी जो कि अक्सर बच्चे बर्थडे के टाइम करते रहते हैं, एक बैलून लेते हैं, बैलून फुला के और उसको रब करते हैं और रब करके वाल के अंदर स्टिक करेंगे तो बैलून वहाँ पे चिपक जाता है, वाल के चिपक जाता है. इट मीन्स कई सारे ऐसे फिनोमेना हैं जो कि चार्जिंग को शो करते हैं, या हम कह सकते हैं जिनके पीछे जो कॉज है वो क्या है, चार्जिंग है. एंड फॉर्मेशन ऑफ क्लाउड इज ऑल्सो रिलेटेड टू चार्जिंग. तो एक बार हम रिकॉल कर लेते हैं कि ग्लास रोड को सिल्क के साथ रब करते हैं तो उसमें चार्जिंग आती है. प्लास्टिक की स्केल को अगर हम रब करते हैं और रब करके उसके पास बिट्स ऑफ पेपर लाते हैं तो उनको अटैच करता है. कॉम्ब को अगर ड्राई हेयर्स के साथ रब करते हैं देन इट ऑल्सो अट्रैक्ट बिट्स ऑफ पेपर. शूज के ऊपर डस्ट चिपक जाती है. तो देयर आर सो मेनी एग्जांपल्स एंड ऑल एग्जांपल्स आर रिलेटेड टू चार्जिंग. और इस टाइप की काफ़ी सारी एक्टिविटी हमने क्लास 7 में पढ़ी. आई थिंक यू ऑल आर रिकॉलिंग दैट. क्लास 7 से हम जानते हैं फिनोमेना ऑफ चार्जिंग. टुडे आई विल डिस्कस दिस फिनोमेना इन वेरी डिटेल. तो फर्स्ट ऑफ ऑल आई एम गोइंग टू डिस्कस चार्ज. The first point I want to discuss here is charge. Charge is the property of matter. Charge is the property of matter which is responsible for magnetic and electric effects of matter. Charge is the property of matter which is रेस्पॉन्सिबल फॉर मैग्नेटिक एंड इलेक्ट्रिक इफेक्ट्स ऑफ मैटर. मैटर का कोई भी मैग्नेटिक और इलेक्ट्रिक इफेक्ट आता है तो अल्टीमेटली इसके पीछे जो लॉजिक है वो क्या रहता है, चार्ज. तो अब हम चार्ज के बारे में थोड़ा डिटेल में डिस्कस करते हैं कि व्हाट इज चार्ज एंड हाउ वी एक्वायर चार्ज. जनरली ग्रीक फिलोसोफर्स, सबसे पहले ग्रीक फिलोसोफर्स और ग्रीक साइंटिस्ट ने चार्ज का डिवाइड किया और ग्रीक साइंटिस्ट ने बताया कि व्हेन ग्लास रोड इज रब्ड विद सिल्क, when glass rod is rubbed with silk, it will acquire some charge. Glass rod is rubbed with silk, then it acquires some charge, and charge developed on glass silk. Charge developed on glass rod is known as or is named as vitreous. Vitreous charge. Charge developed on glass rod when it is rubbed with silk is named as vitreous charge as per Greeks. Here vitro means glass. According to Greek letter, vitro means glass. तो चार्ज डेवलप्ड ऑन ग्लास रोड इज नेम्ड एज vitreous charge. And when amber is rubbed with woolen cloth. When amber is rubbed with woolen cloth, then it also acquires some charge. Charge acquired by amber. Charge acquired by amber when rubbed with woolen cloth is named as resinous charge. Resinous charge. It means initially the charge named as 2. Number 1 vitreous charge, number 2 resinous charge. Number 1 is vitreous charge, and number 2 is resinous charge. Charge developed on glass rod when rubbed with silk is named as vitreous charge. Vitreous charge. And charge developed on resin or amber is known as resinous charge when it is rubbed with woolen cloth. After that, after this nomenclature, Benjamin Franklin, after this nomenclature, Benjamin Franklin named as this vitreous charge as positive charge. Benjamin Franklin named this vitreous charge as positive charge only as convention. These names were given only as convention. Conventionally, he named this vitreous charge. Vitreous means charge developed on glass rod when it is rubbed with silk is named as positive charge. And charge developed on resin, charge developed on resin or amber when rubbed with woolen cloth is known as negative charge. It means now we can say that charges are of two types. Number 1 is positive charge, number 2 is negative charge. We can name as plus Q or minus Q. So these are the two types of charges. One is positive charge, other is negative charge, and this nomenclature is given by Benjamin Franklin. Benjamin Franklin. Number 1 is positive charge, other one is negative charge. So this is the basic introduction related to the charge. There are two types of charges. One is positive charge, other is negative charge. Now unit of charge. Unit of charge. SI unit of charge is Coulomb. SI unit of charge is Coulomb. Fundamental unit of charge. That we will discuss just later on. Fundamental unit of charge, it is equal to the charge of proton or charge of electron irrespective of sign, and it is having value 1.6 into 10 to the power minus 19 coulomb. This is known as fundamental unit of charge, and it is represented by a small e symbol like this in cap, small caps E. Fundamental unit of charge is E. Ampere R. Other unit of charge is also ampere R. How ampere R? I am recalling you from class 10th. Class 10 से आप जानते हैं I equals to Q by T. From class 10 you know I equals to Q by T. Therefore Q equals to IT. It means current multiplied by time will give us charge ampere hour, and we know that unit of time is second. SI unit of time is second. Therefore 1 ampere hour equals to 3600 Coulomb. This is bigger unit of charge, that is ampere hour, 3600 Coulomb. And there is one more bigger unit, that is charge of 1 mole of electron. Charge of 1 mole of electron, and that is known as Faraday constant. Charge of 1 mole of electron, it means 1 mole means here Avogadro constant. Avogadro constant into charge of electron, we will get this value 96500 Coulomb. This is known as Faraday constant, and which is a very bigger unit of charge. So this is what about unit of charge. Unit of charge is Coulomb. Fundamental unit of charge is E, that is 1.6 into 10 to the power minus 19 Coulomb. Ampere hour, very big unit of charge, that is 3600 Coulomb. And then charge of 1 mole of electron, that is also known as Faraday constant, and that is 96500 Coulomb. How it comes? Faraday constant multiplied by charge of 1 electron. Faraday constant equals to Avogadro constant into charge of 1 electron. Avogadro constant into charge of 1 electron, Na into 1.6 into 10 to the power minus 9. We know the value of Na, 6.023 into 10 to the power 23 into 1.6 into 10 to the power minus 19. Then we will get 96500 Coulomb, that is Faraday constant. So this is what about unit of charge. After this, I am discussing some properties of electric charges. Very simple properties of electric charges. First, we can say light charges. Light charges repel each other. Light charges repel each other. It means if this is plus, there will be a repulsive force. This is minus, there will be a repulsive force. Light charges repel each other. Unlike charges attracts each other. Unlike charges attracts each other. If here is plus, here is minus, then we can say attraction. Here is minus, here is plus, we can say attraction. It means like charges repel each other, unlike charges attract each other. Additive nature of charge. Additive nature of charge, it means if we consider a system having many charges, third property we can say additive nature of charges. If a system consists of many charges, for example, here is plus q, here it is minus 3q, here it is plus 5q, and here it is plus 4q. Then total charge of the system is the algebraic sum of all the charges. That is known as additive nature of electric charge. It means here total charge of the system can be written as q plus 5q minus 3q and then plus 4. Total charge of the system will be the algebraic sum of individual charges. Here one is plus q, this is minus 3q, this is 4q, this is 5q, and this is q. Therefore, total charge will be q plus 5q, 6q, 10q, and minus 3q. It means it is 7q. Total charge of the system will be 7q. That is known as additive nature of charge. Fourth property we can also say law of conservation of charge. According to law of conservation of charge, total charge of an isolated system, total charge of an isolated system remains conserved. Total charge of an isolated system remains conserved. How it remains conserved? I am discussing with a very simple example. Let us suppose we are having a body A and other body is B, and initially both are neutral. Initially both are neutral. It means initial charge of A is 0, initial charge of B is also 0. Just after some time I will discuss charging by friction. So let us suppose I rub these two bodies. I rub these two bodies and there is transfer of 2 electrons. There is transfer of 2 electrons from A to B. Just after in the next topic I am going to discuss friction. 2 electrons from A to B. We know that from class 9th you know that whenever a body loses some electron, it becomes positive charge. It means it acquires positive charge. So there is no any gain of positive charge. इलेक्ट्रॉन जाने के कारण वहां पे पॉजिटिव चार्ज एक्सेस हो जाएंगे. जो पॉजिटिव चार्ज पहले थे चार्ज उतने ही है, लेकिन वहां से नेगेटिव चार्ज कम हो गया है, तो इट एक्वायर +2 चार्ज. इट मींस चार्ज ऑफ बॉडी A will be +2e after rubbing and charge of B will be -2e after rubbing. Therefore total charge Q total after rubbing will be 2e and -2e, that is equals to 0, and before rubbing total charge was also 0. It means charge before rubbing is 0, charge after rubbing is 0. So by using this concept we can see that total charge remains conserved. For an isolated system, total charge remains conserved. This is known as law of conservation of charge. Fifth point we can say charge is independent of speed or velocity. Charge is independent of speed. It means पार्टिकल की स्पीड चेंज होने से चार्ज में चेंज नहीं आएगा. There will be no change in charge if there is change in speed. Clear? And fifth, sixth point we can say quantization of charge. Quantization of charge. Just we have seen that whenever we rub two bodies, there may be transfer of some electrons. Therefore, whenever one body is rubbed with other, there may be transfer of some electron. For example, 1 electron, 2 electron, 3 electron, 4 electron. Let us suppose A to B, there are two bodies, one is A, other is B. From A, there is transfer of 4 electrons. There is transfer of 4 electrons from A to B. It means body A acquire +4e charge, when body B acquire -4e charge. It means charge on any body or any system can be expressed as integral multiple of fundamental unit of charge. Q equals to NE. This may be plus NE or this may be minus NE. This is known as quantization of charge. Q equals to plus minus NE. It means एक बॉडी से दूसरी बॉडी में जब भी चार्ज का ट्रांसफर होगा, वो इलेक्ट्रॉन के इंटीग्रल मल्टीपल में होगा. 1 इलेक्ट्रॉन होंगे, 2 इलेक्ट्रॉन होंगे, 10 इलेक्ट्रॉन होंगे, 20 इलेक्ट्रॉन होंगे. And how much electron will transfer from body 1 to body 2, that will depend on the electronic configuration of the metal, electronic configuration of that metal or that atom. Q equals to Ne, that is known as quantization of charge. It means किसी भी बॉडी पे जो चार्ज होगा वो इलेक्ट्रॉन के चार्ज का इंटीग्रल मल्टीपल होगा, या हम कह सकते हैं फंडामेंटल यूनिट ऑफ चार्ज का इंटीग्रल मल्टीपल होगा. Q equals to Ne. Now we are solving 2-3 numericals related to this, and then we proceed for next one. The first question is, that is generally asked in a CBSE exam. Find out number of electrons in 1 coulomb of charge. That is very simple question. Find out number of electrons in 1 coulomb of charge. Just we have seen that Q equals to N, where Q is total charge, N is number of electrons, and E is the charge of electron, value of charge of electron. And therefore, N will be equals to Q by E. Here Q is 1 coulomb, therefore this is 1 coulomb, divided by E, 1.6 into 10 to the power minus 19 coulomb. And if we solve it, we will get 6.25 into 10 to the power 18. It means 1 coulomb of charge will have 6.25 into 10 to the power 18 electrons. And this number is very high. This number is very large, that is enormous number. Okay? 6.25 into 10 to the power 18. Question number 2. Find out number of electrons in 1 microcoulomb of charge. Find out number of electrons in 1 microcoulomb of charge. So now it is very easy, you can solve very quickly. Q equals to N, and then it lies N equals to Q by E. Of that we can say 1 microcoulomb. 1 micro means 1 into 10 to the power minus 6 coulomb, and divided by 1.6 into 10 to the power minus 19. Now you can recall this number. 1 by 1.6 into 10 to the power minus 19, the value of this will be 6.25 into 10 to the power 18. जहाँ कहीं भी आपको 1 upon 1.6 into 10 to the power minus 19 मिलेगा, उसका आंसर क्या होगा? 6.25 into 10 to the power 18. No need to divide again and again. Therefore, we can directly write 10 to the power minus 6 as it is into 6.25 into 10 to the power 18. And therefore, it becomes 6.25 into 10 to the power 12. Here it is minus 6, here it is minus 6, and it is 10 to the power 18. Therefore, it directly becomes 6.25 into 10 to the power 12. It means now we can easily find out the number of electrons in different situations. For example, third question I am taking. Question number 3. Find out number of electrons in number of electrons in 1 nanocoulomb. Now we can very easily write the answer, and answer we can view very quickly. 1 nanocoulomb, it means in this case N equals to Q by E, and now we can directly write the answer. 6.25 into 10 to the power 18 and scenario is 10 to the power minus 9. And finally we can directly write the answer 6.25 into 10 to the power 9. This much of electron will be there. Find out number of electron in 1 nanocoulomb of charge, we can get the answer. Now we are discussing some different question again related to quantization of charge. Question number 4. Find out total positive and negative charge of 18 gram of water. This is quite different question. Find out total positive and negative charge of 18 gram of water. This is question is related to NCERT example. So before finding out total positive or negative charge of 18 gram of water, first of all we have to find out how many molecules of water will be there. And then we find the charge of one molecule of water, and finally we can find the total positive charge or negative charge. So first of all, total number of molecules of water. Total number of molecules of water. So here it is given 18 gram, and we know that molecular weight of water is 18. Therefore, it will be 18 divided by 18. It means it will be 1 mole of water. 18 gram of water, it means we are considering 1 mole of water. Therefore, total number of molecules will be 6.023 into 10 to the power 23. It means total number of molecules 18 by 18, that is 1. It means it is 1 mole, and 1 mole of water contains 6.023 into 10 to the power 23 molecules of water. Now, if we talk about 1 molecule of water, that is H2O, it means it contains 2 plus 8, that is 10 electron and 10 proton. 10 electron and 10 proton. A single water molecule consists of 10 electron and 10 proton. It means total number of electron or proton we can easily calculate, and we will calculate here only total number of electrons because it is equals to total number of proton, and then we can multiply that by the charge of single electron. Therefore, we will get total negative charge, and total negative charge will be equals to the total positive charge. Therefore, I am writing directly total negative charge equals to total negative charge equals to, first of all, how many moles, how many molecules, that is 6.023 into 10 to the power 23. This much of molecules of water there will be in 18 gram of water, number of molecules, into how many electrons in one molecule, that is 10, so we have to multiply by 10. Now, how much charge of 1 electron? That is 1.6 into 10 to the power minus 19. This much of total negative charge will be there. Calculation you can do very well, no problem. Total negative charge will be equals to this, and we can put the unit as Coulomb. This is the total negative charge of 18 gram of water. How we have calculated? 18 divided by 18, that will become 1 mole. 1 mole into Avogadro constant, therefore it will be 6.023 into 10 to the power 23 molecules, and 1 molecule contain electron 10, therefore this Avogadro number, that is number of molecule into number of electron in 1 molecule, and then total charge of 1 electron. So this is total negative charge of 10 gram of water, and it will be equals to टोटल पॉजिटिव चार्ज. जितना टोटल नेगेटिव चार्ज आएगा उतना का उतना टोटल पॉजिटिव चार्ज आएगा. एंड नाउ question is asked, what is the net charge? Net charge will be 0 because total positive charge and total negative charge both are same. This is question number 4. Now I think you are easily understanding the quantization and how we can calculate the charge. Finally, we can also solve one more numerical again related to quantization of charge. Question number 5. Find total charge of 1000 electrons. Very simple question. Find out total charge of 1000 electrons. We can directly write Q equals total charge of 1000 electrons. The number is 1000 and we can multiply by 1.6 into 10 to the power minus 19 coulomb, but that will be negative charge. 100 into 1.6 into 10 to the power minus 19 coulomb, or that we can also write 1.6 into 10 to the power minus 16 coulomb, or that is negative charge. We can also solve another numerical. Let us suppose, hypothetically we assume that there is a system having 7 proton and 5 electron. A system is having 7 proton and 5 electron, and we have to find out net charge. Q net means we have to find out net charge of the system, or we can say total charge of the system. So this question we can easily solve. Q total equals, since it contains 7 proton, it means 7 into charge of proton is E, so 7E, plus 5 electron, charge of electron is minus E, so that is 7E minus 5E, that will become 2E, and therefore it will be 2 into 1.6 into 10 to the power minus 19 coulomb, or that we can also write 3.2 into 10 to the power minus 19 coulomb, and this will be positive charge. So by this way we can find out total charge of a system, or we can also find out how many electrons or how many protons if the total value of charge is given. Now I am recalling once the topics we have discussed. Here in this class we have discussed electric charge and their properties. Charges are of two types. One is positive charge, other is negative charge. Initially they are named as Vitreous charge and Resinous charge, but Benjamin Franklin named these two charges as positive charge and negative charge. Charges show additive nature. Total charge will be the algebraic sum that we have discussed in numerical. Like charges repel each other, unlike charges attract each other. And electric charges are responsible for all the electric and magnetic effect of the matter. And we have also discussed the unit of charges and different unit of charges, that is SI unit is Coulomb, smaller unit that is unit of charge, that is charge of electron, that is also known as fundamental unit, 1.6 into 10 to the power minus 17 Coulomb. And then we have discussed a very bigger unit that is also a practical unit, ampere hour. 1 ampere hour equals to 3600 Coulomb. And we have also discussed Faraday constant. Faraday constant is total charge of 1 mole of electron, that is known as Faraday constant, and it is having value 96500 Coulomb. Thank you.